Hi guys, this is Miss Jones. I'm going to be doing your notes again tonight, and your notes are going to be on so this shouldn't be too bad at all. So to start off, you folks need to know what density is. So density is defined as the amount of matter in a given volume of substance. So it's the mass per unit volume. And it can be defined really easily in a simple equation where density equals the mass divided by the volume. And this is an equation you all have seen before because we did this in your block lab that you did the other day in class, where you found out what the mass of each of the blocks were. You used the same density equation, so you should be familiar with it. So, important things to know about density is that density is an intensive property. What this means is that it doesn't depend on how much of the substance there is. So no matter how big or how small your sample is, the density will always be the same. It never changes. So what this means is that density can be used to identify a substance. So say we had a sample of copper. If we had, half a gram versus, a kilogram, it would still be the same density. And densities are pretty unique to the substance, so we're able to use them to identify something if we're not sure. If we have the mass and the volume, and we find the density, we're generally able to figure out what the identity of that substance is. So here's an example problem where we have what's the density of an unknown material that's 233 grams and has a volume of 26 cubic centimeters. So we know that we're going to use our problem. So we have density equals mass over volume. Alright, and so then we have 233 grams divided by 26 cubic centimeters. And if we do this problem, we get 8.9615. But we know that we have to pay attention to sig figs, so we look, and since it's a division problem, we go by least number of sig figs, so 26. There's 2 sig figs here, so we need to round to 2 sig figs. So this becomes 9.0, going by our rounding rules. And in the last video, we also talked about units, so you have to include units. So this would be grams per cubic centimeter. Then, if we asked you what the actual identity of this material was, and we gave you a chart, you could look through this, and you could go down and look at these densities. So, go down and look at these densities. We see that it's none of these. And then we look over here, and we see that copper has a density of 8.96. And we know that's what it was before we rounded, so we can say that the identity of that material was, in fact, copper. So one more example problem. If we have the density of lead being 11.34 grams per cubic centimeter, what would be the volume of 186 grams of this lead? So now we have it in a little bit different way. So we know again that our equation is density equals mass divided by volume. But this can be rearranged to say volume equals mass divided by the density. So volume again equals, and we'll have that's with a mass, so 186 grams divided by 11.34 grams per cubic centimeter. And this will give us 16.402. But again, we know we have to use correct number of sig figs. So looking at this, we see we had 3 sig figs in the top, so we have to have 3 sig figs in our answer. So our final answer will be 16.4. And then we look at our units, the grams cancel out. So we're left with 16.4 cubic centimeters, which is what we want because that is an answer in volume. So that's what you get. And that's all your notes that we have for tonight. Again, I said it was pretty short. So I hope you understood everything. If you have any questions, you can ask us next block. Bye.